Okay. Once again, just this is the given differential equation dy by t is equal to f of y of t, y comma t. If t is independent variable, y is dependent variable, y of t naught is equal to y naught. So the MATLAB providing different solvers depending upon the method. So ODE 45 is dependent on Renal-Kutta fourth order method. ODE 23 is dependent on Renal-Kutta method. ODE 113 is dependent on Adams method, like that. Using these solvers, we solve ordinary differential equations. The syntax of ordinary differential equation is like this solver. So we can use either ODE 43, ODE 113, depending upon your differential equation, we take solver here. ODE 1 is M5. ODE M5, we create one M5 and we write the differential equation that M5 and we save that file and we keep in the folder. T-span is here given value y of t naught is equal to t y naught. Suppose t naught is equal to 0 and y naught is equal to 1. Y of 0 is equal to 1. I would like to find out the y value at t is equal to 2. So my t-span is 0 to 2. 0 to 2. That we have to mention here, t-span. Y of y naught. For that example, y naught is 0. Y naught is 0. Okay. So first we create one M file and in that M file we write a differential equation. Okay. That I will tell you. I will take one problem and I will tell you how to write a M file. Okay. Next t-span. So vector specifying the interval of integration. Interval of integration is interval of integration. For t-span, vectors with more than 1, 2, that I will tell you one by one. So many options are there in t-span. Just I give an introduction. What is a t-span? So y of t naught, initial condition of the given problem. That is y naught. Suppose I want to solve this differential equation. Okay. So my differential equation is dy by dt is equal to y square plus 3t. Y of 1 is equal to 1.2. Using ODE, whatever it may be the solver, I am taking using 45, 40, ODE 45 solver at t is equal to 1.5. T is equal to 1, t is equal to 1.15. My t span is 1 to 1.5. Okay. My t span is 1 to 1.5. So y of 1 is equal to 1.2. Y naught is this one. We have to create M file like this. Okay. My differential equation is dy by dt is equal to y square plus 3t. Y of 1 is equal to 1.2. That is my differential equation. We take one. First, we have to write this. So first, we have to create one file that in function format. Function f is equal to any name. KSR, maybe KSR is there. B4, that is better. 22. B4, 22. What are the input values? Only two values: independent variable and dependent variable. Independent variable and dependent variable. Independent variable is t. Dependent variable is y. These are the input values. What is my output? F is nothing but a differential equation. What is the differential equation? F is equal to y square plus 3t. Y square plus 3t. 3 star t. Semicolon end. So if you call this function, it takes y square plus 3t. Am I correct or not? If you call this function, it takes y square plus 3t. I am saving this file. If you have any doubts, I will tell again. B of 422. Okay, my file name is B of 422. B of B422 of t is equal to 1, t is equal to 1, y is equal to 4. It calculates y square plus 3t. Am I correct or not? Y square plus 3t. Y square plus 3t. That is output value. This is output value. F I assigned to that F value. Okay. F value. Suppose value is equal to B4 up to 2 of 1 comma 2. Usually we write a differential equation like this. Am I correct or not? If you take a Euler's method, Euler's method or Lange-Gutta method, modified Euler's method. So every time we concentrate on the right hand side. Am I correct or not? If you want to solve a differential equation using numerical methods, we concentrate on the right hand side. dy by dt is equal to dy by dx or whatever it may be. Dy by dx is equal to f of x by f of x. F of x by is the important value for us, not dy by dx in the numerical methods. Am I correct or not? This is very important for me. This is very important value to solve a differential equation. So for our differential equation, dy by dt is equal to. So we all know what is the importance of numerical methods. I don't no need to tell the importance of numerical methods. Y square plus dt. It is very difficult to solve this differential equation using analytical method. So we have very few methods to solve ordinary differential equation, first order differential equation, variable separable method, homogeneous, reducible to homogeneous, exact, linear. Exact, linear also one of the methods of exact, linear, reducible to Bernoulli differential equation. Like the very few methods are there. So if you take this differential equation, you cannot solve any one of the methods which I mentioned earlier. dy by d is equal to y square plus 3t. It is very difficult. It is not a linear. It is not an exact. Am I correct? You check it. You check it. It is very difficult. So definitely in that case, we have to depend on numerical methods. In numerical methods, if you depend on the numerical methods, right hand side is very important value, not on the left hand side. Right hand, this f of x comma y, x t comma y, whatever it may be, f of t comma y. Place vital role. That's why I created one M file for this right hand side, y square plus 3t. That is this M file. B4 double 2. B4 double 2. The output of the function is f. F, you can mention anywhere dy dt, dy dt, not a problem. But here we have to mention dy dt. Output I am assigning to that. No need. F, you take f, not a problem. Okay, save. Only the right hand side, I am concentrating on the right hand side. My file name is B422. My file name. Okay. I created ODE fun. This is the name of the here I wrote as ODE fun. The previous slide. This ODE fun is B422. My file name. What is my T-span now? My T-span is 1 to 1.5. I want to solve the differential equation at T is equal to 1.5. From 1 to 1.5. That is my T-span. What is initial value? 1.2. Okay. So if you enter this command in command window, you will get the output. Okay, we'll check it. See. So t comma y. Okay, t comma y is equal to ODE45. That is a solver name. Nothing is ODE45. That's like a square root of function, square root of something, a sine of some function. It is inbuilt function. I will write instead of ODE45. I will create one M file. Is a ODE45 is a solver to solve a differential equation. I will write one program to solve a differential equation. That's my file name, maybe KSR1 or KSR2, like that. Okay, that I will do later. Okay, ODE45. So what is the file name? My differential equation is in B422. That is my differential equation. Comma, what is my T-span? 1 to 1.2. Something is there, 1 to 1.5. 1 to 1.5. That is my T-span. What is the Y naught value? Y naught value. Y naught is 1.2. 1.2. now I have a solution. What is the solution? T comma y. Want to write solution side by side. This is the solution of the differential equation. So at initial value at t is equal to 1, the function value is 1.2. At 1.5, the y value is 26.5412. So initially in the classroom we take, we divide. Suppose you want to find out, you want to solve the differential equation. If you want to solve this differential equation at t is equal to 1.5, we calculate t is equal to 1 and 1.1, 1.1, 1.2, 1.3, 1.4, 1.5. Maximum we do 5 iterations. Am I correct or not? In the first, we take h is equal to 0.1. We calculate at 1. Initially y naught, t naught value is equal to 1. T1 is equal to 1.5. That is t naught plus h. T2 is equal to t naught plus 2h. T3 is equal to t naught plus 3h. T4 is equal to t naught plus 4h. T5 is equal to t naught plus 5h. Finally, we'll get some value. That is, we say that there is a solution. Here, MATLAB is calculating more than by default. OD45 calculates 45 points, 45 intermediate points. So, what is the size of P, for example? Now, my size of P is 45 points. Did you understand my point? For example, size of t comma y. Above vector is there, so 45 rows and 2 columns. Here 45 rows and 2 columns. 45 rows and 2 columns. So 1, 2, 3. So by default, if you use the body 45, it calculates 43 intermediate points. It takes 43 intermediate points. First point is the given value. 45th point is our solution. Okay. Now, if you plot this one, what will happen? Plot t comma y comma colon. This is the solution. So we have, this is the numerical solution actually. Am I correct or not? These are the these values are the first value. It is at x is equal to 1, y value 1.2. Like this. We have 45 points. Am I correct or not? So 45 points, we have a scatter diagram. If you want to know the analytical solution approximately, you take a toolbox, arithmetic toolbox, CF tool. We have a data. X values are x, t. Y values are intermediate values. Y values are x value. Create data set. Close. Okay. You fit the curve. You will get approximate U fit. Okay. It's a polynomial. You take a quadratic polynomial. Check it. What will happen? It look like a quadratic polynomial. Fit apply. It's not satisfying. Am I correct or not? It's not satisfying. So let's say exponentially go for exponential. So I'm concentrating on, I hope you understand, analytical solution. What is the analytical solution of this one? Apply. It's not good. We take this one, apply. So we have a approximate solution now. The approximate solution, this one is, the error is very less and it is passing to all these points. My solution is y is equal to a into e power bx. Y is equal to, my solution is for this differential equation, my solution is equal to y is equal to a into e power bt c into e power dt. A, B, C, D are given like this. A, B, C, D values are given like this. A, B, C, D values are given like this. A is this one, B is this one, C is this one, D is this one. Okay. Now I have an analytical solution also. Not exact analytical solution, approximated analytical solution. Okay. Approximate analytical solution. So actually numerical methods, there is no need to analytical solution. We need a value at what is the y value at a given point. That we have now. Now my question is, so no, I don't want any. No. So actually here we have a solution like this. We have a solution like this. So I want a solution at 1, 1.1, 1.2, 1.3, 1.4, 1.5. Can we do that one? Yes, we can do it. So I want at particular points 1, 1.2, 1.1, 1.2, 1.3, 1.4, and 1.5. That we can do by taking this like this. We change in T span. We change the T span. So 1 colon 0.1 colon 1.5. What is T comma? That is my solution. T comma. That is 1. That is 1. 1.2, 1.1, 1.7271, 1.2, 2 point like this, 1.5. Okay. Okay. This is about this is the method to solve ordinary differential equation using solvers. That's a main disadvantage of solvers is solvers means so that is the difference between MATLAB program. Whenever we start a MATLAB program, participants will be very bored. Why? Because if you take the solver directly, it will come the solution. Am I correct? OD45 is the solver inbuilt function, ready-made. Ready-made sets are very famous than traditional stitching sets. Am I correct? Like this, OD45. It is a ready-made. It is available in the market. You are utilizing that market. But if you want to solve, if you want to if you need a separate shot with your own design and like this, we have to depend on the stitching. Okay. So at that time, MATLAB programming plays vital role. So we can so not only differential equations, so many problems will come. Natural problems. If you take any practical problems, we need definitely we have to depend on programming. So for example, I want to create a big matrix like this. So once again, I'm stressing the importance of programming. For example, I am opening one of my M files, my papers, for example. For example, this is not yet published in this paper. At present, we are working on this one. I'm concentrating on matrices, for example. And this is the matrix, a special type of matrix came here. I need eigenvalues for this one. Suppose these are the values, it is not a problem for me. Am I correct or not? M plus 1, M plus 1, M plus 1. It is a constant, we can easily find out the eigenvalues. Yes or no? Suppose it is a variable, how can you, in MATLAB, will not give the eigenvalues? Did you understand my point? I hope you understand my point. Okay. Suppose I want to create a matrix like this, I need eigenvalues for this matrix. How can you, it is 3 by 3, not a 3 by 3. It is not 4 by 4, it is n by n matrix. How can you enter this n by n? How can you guess the eigenvalue? Suppose it is 4 by 4 matrix, I will enter the matrix. First of all, how to enter this matrix in MATLAB? It is in a systematic manner. The elements are arranged in a systematic manner. We cannot find any inbuilt function to enter this type of matrix. I hope you understand my point. The matrix is arranged in a systematic manner. I need an eigenvalues for n by n matrix. These inbuilt functions are not useful. Will not give an answer to find out n by n matrix. Definitely we have to depend on the program. We have to write one program. We have to create a matrix of n by n. Whatever it may be, that function input is n. If you give n 10, automatically I have to get a 10 by 10 matrix. If you give n is equal to 100, automatically we have to get a matrix 100 by 100 matrix. 100 by 100 matrix. Okay. With that 100 by 100 matrix and 10 by 10 matrix, 20 by 20, 30 by 30, 40 by 40, 50 by 50, I have to find out n by n eigenvalue. I have to guess the eigen by n eigenvalues. Otherwise, you have to write a program to find out the n by n eigenvalues, n by n matrix eigenvalues. You do understand my point? At that time, these inbuilt functions will not help you. These inbuilt functions will not help you. Okay. So each inbuilt function is dependent on one algorithm. One algorithm, that is an algorithm, one inbuilt function. Suppose SQRT of something is there, sign of something is there. There is a program behind that one. B444, I showed it before. That's why I showed before something. B424, B4, it is a function here for me. B424 is a function, sign of like this, sign of x, sign of 1, 4. If you give that value, answer is coming. Am I correct or not? If you give SQRT of 3, SQRT of 2, answer is coming. There is a program, inbuilt program, to find out the square root. There is a program, sin pi by 3, and giving input is pi by 3. There is an MPile in MATLAB to calculate sine values. I hope you understand my point. So like that, before double two is my file to find out the function value. Similarly, trapezoidal rule. Trapezoid function is there. I told trapezoid function is the inbuilt function is there. I wrote my own program to find out the integral value using based on the trapezoidal rule. Okay. So this programming is very, very important. You have to concentrate on if you want to become a master in MATLAB, not only in MATLAB, in C or C++, Java, whatever it may be, you should be perfect in programming. Then only you will become a master in that area. Don't depend on inbuilt function. Sometimes there's no problem. So when actually, if you enter into your own problem, that programming plays vital role. So these are the examples I am explaining. Suppose this is a problem, matrix. This is a matrix is there with me. I need an eigenvalues for this one. So I need a spectrum for this one. 0, n minus 1 up to 1, n minus 1. First of all, how to create a matrix like this? That is the first question. 0, n minus 1, n minus 1, n minus 1, 0, 0, 0, n minus 1. Suppose 0, 10, 10, 10, 10. 10, 0, 10, 10, 10. That is 10 by 10 matrix line. How to enter that matrix? Suppose if it is a one matrix is not a problem. I can enter. If you give an n, I have to get a matrix. 10. If you give 100, I have to get 100 by 100, this type of matrix. That is the first step. If you give 200, I have to get by 200 by 200 matrix of type this. If you give input is 100 for me, if you give an input as 100, I have to get a matrix 0, 99, 99 up to 99. 99, 0, 0, 99, 99, 99. Like that, 99, 100 by 100 matrix I have to get. It is very difficult to enter manually. Am I correct or not? It is very difficult to enter manually. For each time, how can I enter 10 by 10 matrix? It is 10 by 10, okay. If it is 20 by 20, how difficult it is? Am I correct or not? So, every time, if you want to make your practice, if you want to make simple, you have to depend on programming. So, my techniques are there. So, every time I depend on my programming. I will write my own program to solve my problem. Okay, that is the thing. So, don't feel it is hard. It is very difficult to understand. Don't feel. So there is a beginning, I explained, but gaps are came 2 days, 2 days, 1 day, like that I told. Suppose it is a matrix like this, tridiagonal matrix. How to enter tridiagonal matrix? How to create a tridiagonal matrix in MATLAB? All diagonal elements are C. First, we have to concentrate on this one. Later, we can get some information about the matrix. C, diagonal matrix are C. Above diagonal matrix are some constant. Below diagonal matrix are constant. Remaining values are zeros. For a given 10 by 10 suppose if it is n by n matrix, actually here, this is n by n matrix. 10 by n matrix, 100 by 100 matrix, I need a tridiagonal. Tridiagonal means like this. Tridiagonal matrix means like this. Suppose 1, 2, 1, 1, diagonal 1, 1, 1, all ones. Here 2, 0, 0, 0 like this. Again here 3, I'm taking 3, 2, 0, zeros. Again 0, 4. I'm taking a different number or 5, whatever it may be. So 2 here, zeros, all are zeros. Like this, it will come tridiagonal matrix. Everyone knows the tridiagonal matrix. First diagonal, principal diagonal, upper diagonal, lower diagonal. Remaining elements are there. How to create a matrix like this in MATLAB? Generally, we can enter. For 3 by 3 matrix, we can enter. 4 by 4 matrix, we can enter. 5 by 5 matrix, we can enter. So I need, for a given n value, I have to get a tridiagonal matrix. Suppose 20 I given. I have to get a tridiagonal matrix like this. 20 by 20 tridiagonal matrix like this. How to get it? These are the things at the time MATLAB plays vital role. Programming plays one vital role. Okay. Okay. That's I want to tell the importance of programming. If a particular tridiagonal matrix is given, we can find the determinant value, inverse, eigenvalues, and eigenvectors. That is not a problem. Suppose if it is n by n, 100 by 100 matrix, how can we enter 100 by 100 tridiagonal matrix? It is very difficult, Definitely you have to depend on programming. If you give n is equal to 100, I have to get 100 by 100 matrix, and that program should create a tridiagonal matrix. These are the things we have to concentrate in programming. So there are inbuilt functions. I'm telling how to create a tridiagonal, how to create a circular matrices and all these. There is a inbuilt functions are there. Sometimes we cannot create exact tridiagonal matrix. Our values may be differ. Okay. So if you practically solve the problems, we can face so many problems. That I'm leaving. Now that is the important difference between I'm telling. If you tell like this, it is very easy to solve the ordinary differential equation. Am I correct? So can we write a program to solve your ordinary differential equation? That is my next question. Suppose ODE 45, there is a method is there. Rangakutta fourth order method. We know the Rangakutta fourth order method. We are solving the classroom. So that is some method is there. We have to apply that method. We have to create one M file using that method. That is the next step. So I will solve 2, 3 or 4 problems. Then I will concentrate on programming. I will write my own solver here. If this is the inbuilt solver, I will write my own program. I will write my own program to solve the ordinary differential equation. That's the next step. Okay. This is now solve dy by dx is equal to y square minus x square by y square plus x square given by naught is equal to 1 at x is equal to 0.2, 0.5 using Rangakutta method. This is Rangakutta method. I am not touching this Rangakutta method. I want to solve the given differential equation in the span 0 to 0.4. Okay, my differential equation is dy by dx is equal to y square minus x square by y square plus x square. We can solve this differential equation using analytical method also. So what is this differential equation? This is a homogeneous differential equation. Am I correct? dy by dx is equal to f of xy. F of xy is a homogeneous function of degree 0. Y square minus x square by y square plus x square is a homogeneous function of degree 0. So we can easily solve using analytical method by substituting y is equal to vx. Okay, and that method we know. We studied and we learned in the degree and PE PG also. And that we are not concentrating, and that I am not concentrating. Now my concentration is to solve this differential equation using MATLAB. What is my function here? I am changing the same function I am using. Here very important, variables are very important. T. So T is X here. T is y square. That means y cap 2 minus T cap 2 or X cap 2 you take. If you take X, you take here X. X. Here also independent variable, dependent variable. You have to do like this. First, we have to mention independent variable, next dependent variable. Here X. X square by y cap 2 plus X cap 2 is my differential equation. How we save this one? Okay, I saved this differential equation. My solution is how to find T comma T is X comma Y is equal to ODE 45. My function is B4 22 T span. What is the T span? T span 0 to 0.4. I need a solution. 0 to 0.4. 0 to 0.4. What is the initial value? Again, we have to depend on the initial value is 1. Comma, I forgot comma here. Okay. Now the solution is X comma Y. 0 to 0.4. This is the solution. At x is equal to 0, solution is 1. At x is equal to 0.4, 1.3537, 1.3753. Okay. If you want, you can do like this also. 0, 0 colon 0.1 colon 0.4. You give like this. Am I correct? It is correct, I think. Okay. X comma at 0, this is the value. 0.1, this is the value. 0.2, this is the value. 0.3, this is the value. 0.4, this is the value. Okay. Okay. That is about this one. This is about, no, I am not concentrating. This is very simple. If we use solvers, we can easily get the solution. This is not a big issue. So only thing is we have to create one M file properly. We have to create one M file properly. We have to create one M file properly, and we have to solve the differential equation. In solver, we have to mention M file, T span, Y naught. So now you concentrate on the second problem. First problem is so the differential equation is why I'm concentrating on the second one. It is interesting one. Interesting differential equation, this one. So my differential equation is dy by dx dy by dx two things I will do with this problem, with this problem. 3 into e power x. Some students are there, scholars are there. So kindly let me know how to solve this differential equation analytically. Y of 0 is equal to 0. Leave it, y of 0 is equal to 0, leave it. That is initial condition. Y of 0 is equal to 0. My question is how to solve this differential equation analytically. Anybody? Some scholars are there, students are there, MSc students. MSc students are there, PG, teacher scholars are there. Anybody?
Sir, it's linear, na sir, we can solve.
Yes, sir, yes, sir, yes, sir.
Linear first order.
Linear differential equation. Am I correct, sir? It is a linear, first order linear differential equation. So we can easily solve the differential equation. dv by dx is equal to linear equation, linear differential. Mamta Kumari also told it is a linear differential equation. Linear equation in y. Am I correct? Linear differential equation dv by dx. dv by dx plus p of x into y. That is p of x is minus 2a. Don't feel poor. I need the solution. Minus 2 into y. That is p of x into y is equal to q of x. Q of x is 3 into e power x. P of x is a constant. Q of x is 3 into e power x. And the solution of the linear differential equation is y into e power integral p dx. Integral p dx 2 dx is equal to y into integral q of x 3 into e power x. This value, integrating factor, that we call it integrating factor, that is e power minus 2x. Direct I am writing minus 2x dx plus constant is very important for us. Okay. Plus now we need the solution for this one. So what is y? Now y is nothing but y into e power minus 2x. Y into e power minus 2x. Y into e power minus 2x. Actually I need by value. I will do later. 3 into e power minus x. 3 into e power minus x, that is integration is minus 3 e power minus x. Any corrections? Let me know. E power minus x is minus e power minus x. Let's see. So finally I have a solution. Y is equal to my solution is y is equal to minus 3 e power x. Am I correct or not? Minus 3 e power x plus c into e power 2x. C is an arbitrary constant. So with this initial condition, we can find out the C value. Y of 0 is equal to 0. 0 is equal to x is 0 minus 3 plus C plus C. X is equal to 0. This value 1. This value 1. So C is equal to 3. C is equal to 3. So finally, I have a solution. This one. The reason to solve this analytical solution, I want to compare analytical solution with the MATLAB algorithm solution. That's the thing. Why? Y value. What is the y value now? C is equal to 3. C is equal to 3 means you substitute C is equal to 3 here. 3 is common. 3 into e power 2x minus e power. Correct? C is equal to 3. 3 is common, e power 2x minus e power x. Am I correct or not? Any corrections? Whether I calculate correctly or not? Yes or no, sir? Any mistake?
Okay, sir. Correct, sir.
Correct. Okay. Y is equal to 3 into e power 2x minus e power x. This is the analytical solution for this differential equation. Okay, keep that one. Now I want to solve this differential equation with MATLAB first. Then after we compare the solutions. My differential equation is here. My differential equation is this one. 3 e power x plus 2y. 3 star e power x, exp of x plus 2 star y. This is my f divided by x. Right, save, minimize. Okay, close, minimize. Y of 0 is equal to 0. You remember that point. Y of 0 is equal to 0. Now x, y, this is my y of 0 is equal to 0. 0 to I want to solve at y of 0 is equal to 0. Okay, y of 0 is equal to 0. Oh, what is this one? Again, comma y. Okay, x comma y. My solution is this one. Into 10 to the power of 3 is there. Into 10 to the power of 3. Into 10 to the power of 3. 10 to the power of 3 means last value 10 to the power of 3 means it will come 3. The solution is 151.1.150 something is given. If you want to know the plot x comma y, get a plot. This is the solution. Okay, this is the solution. It is an exponential curve. 3 into something is there. Already we have analytical solution. Okay, analytical solution we have. It is almost same as that one. Might be some of that. Now this is one x comma y. Numerical solution is there. Numerical solution is there with me. Okay, numerical solution is this one, x comma y. This is my numerical solution, MATLAB numerical solution. Now I want to find out the analytical solution values. So what is the x value? Not instead of x, I am taking x1. Understand carefully. x1 is equal to linked space, or otherwise this x values are same. X values already there. Y values I am calculating using the function. What is my function? Y is equal to y1 is equal to y1 is equal to y1 is equal to what is my function? 3 star y1 is equal to 3 star. What is my solution here? 3 star e power 2x minus e power x. exp of 2 star x minus exp of x. So this is these y1 values are analytical solution values at a given these x values. These y values are MATLAB solution values. I want to compare. First value is x space y is the given xy values, analytic MATLAB solution value. X comma y1 is my MATLAB solution values. I'm sorry, analytical solution. You see this one. Almost same. This is analytical solution. Sorry, MATLAB solution. This is analytical solution. There will be a difference. Definitely, there will be a difference here. So format long. If you take a format long, the analytical solution will give a different from the MATLAB solution will give a different value. So 1.150029 is the analytical solution value. So 1.150068 is the MATLAB numerical solution. I hope you understand. This is the MATLAB solution. This is the original solution value. The difference is very small. Am I correct? So after up to 4 decimal places, answer is same. Did you understand? Did you understand? Did you understand my concept? So I solved one differential equation analytically, and the same differential equation I solved ODE 45 solver. ODE 45 solver. ODE 40. I compare both the solutions. Analytical solution. I compare the numerical solution with analytical solution. Definitely we'll get an error, no doubt. We cannot expect 100% accurate value from the numerical methods. Numerical method. Okay, that is the thing. If you have doubts, you can ask now. Then I will take the same differential equation. I will solve using. Yes, tell me what is your doubt there. Okay, format I am taking. Okay, now my idea is I want to write my own program. I want to write a program for Rangikutta method. Rangikutta fourth order method. What is the Rangikutta fourth order method? First, we should know the Rangikutta fourth order method. Then we can write a program. Am I correct or not? We should know the Rangikutta fourth order method. Then only we can write a program. Which is the right answer. Same differential equation I copied there. So this is the Rangikutta fourth order method. Using Rangikutta method of fourth order, solve dy by dx is equal to y square minus x square by y square plus x square with y of 0 is equal to 1 at x is equal to 0.2 and x is equal to 0.4. So if you want to solve this differential equation using Rangikutta method, we take f of xy is the right hand side value. Am I correct? F of xy is equal to y square minus x square by y square plus x square. To find y of 0, y value at 0.2, we take x value as 0, y value is 1, h is equal to 0.2. Am I correct or not? This is the method we explain to the students like this one. Okay? X is equal to 0, given value, y is equal to 1, h is equal to 0.2. We are going to find out y of x plus h. Y of x plus h means 0.2, y of 0.2. First we will calculate k1 value. K1 is h into f of xy. H into h into f of xy. H is 0.2. F of xy means the right hand side value at x is equal to 0 and y is equal to 1. This is the value. K2 will calculate K2. K2 is equal to h into f of x plus h by 2 y of y1 plus k1 by 2. I got this value. So K3 will calculate K3. So like h into f of x plus h by 2 y plus k2 by 2. This is the value. K4 value h into f of x plus h y of y plus k3. That is this value. Finally, we'll calculate k value. K value is 1/6 of k1 plus 2k2 plus 2k3 plus k4. That is this value. Function value y at 0.2 is y value. That is y of y value. Y is 1 plus this increment value. This is the solution at y is equal to 0.2. So if you want to find out y value at 0.4, y value at 0.4, we take x is equal to now 0.2, y is equal to this value. Am I correct, Anand? Y is equal to this value. H is equal to again increment value 0.2. I didn't explain here. I didn't mention all these things. Again, we repeat these values again. Again, we'll calculate k1, k2, k3, k4, and we'll get a k value, and we'll get y value at x is equal to 0.4. So this entire thing I want to write it as a MATLAB program. It is very simple actually. One step, single step, it is very easy. Am I correct? So how to write? Try to concentrate on this one. This is the exactly here one program. Here also it is there. I think so. Here I explain here. Here I wrote everything. To find this is y of 0.2 is equal to 1.16196. Next, to find y of 0.4, x is equal to 0.2, y is the previous value, h is equal to 0.2. Again, we'll calculate k1, k2, k3, k4, and k value. This is the value. Similarly, we get y of 0.6 is equal to 1.5331. For y is equal to y of 0.6, x is equal to 0.4, y is this value, h is 0.2. If you repeat this these steps, you will get y of 0.6 is 1.5331. Okay. Now I want to write a program for this one, MATLAB program for this one. So first, what we have to do? I'm taking the same file and removing this one. Later I create a file. What is the first value? What is the first value? We have to define a phi of value. F is equal to at the rate of x comma y. Am I correct or not? X comma y. The function is y square minus x square square by y square plus x square. Am I correct or not? Yes or no? First we have to define f. Everything is dependent on f of x, y. Am I correct or not? What is x value? X is equal to first value. X is equal to 0. Y is equal to. Later I will use for loop and everything. First I am concentrating on this value. This value. I am entering this entire all steps. Okay. Y value is 1. Am I correct? H value is. Later I will change the entire program. 0.2. Okay. 0.2. Semicolon. First we calculate K1. How to calculate K1? K1 is equal to h into of x comma y. That is a K1 value. Side by side we can write h into f of x plus h by 2 comma K1 by 2. K3 h star f of x plus h by 2 is also K2 by 2. Then K3 will come as direct K2 by 2. K4 will get K3. K4 is equal to h star of x plus h comma y plus K3. Okay. Now K1, K2, K3, K4 is there. Now we'll calculate K. K is equal to 1/6 of 1/6 of K1 plus K2 plus 2K3 plus K4. Okay. Then my solution value, SYF solution is my y plus k. Y plus k is my solution. Am I correct or not? If you run this program, we will get y value at the solution value is nothing but solution is 0 point. It came 0 point. By 1, no?
Sir, line 5 and 6, y plus is y is missing, sir.
Yes. Oh, sorry. Thank you, sir. Y plus here y plus. That's why it is coming different answer. Yes, 1.196. Okay. So with a single iteration. Now, suppose if you want to find out y value at this, what is the solution value? Y value at 1 point. 1 second. Okay. Now this is my, what is this solution value y plus k? Y value at 1 point. Am I correct or not? Y value at 1 point. So let like this. Now in the next iteration, in the next step, so we have to repeat this loop to find out different y values and different given x values. So how to develop this one, that we'll see in the next class. Did you understand my point? So this is the basic. I calculate only y value at given x value at x is equal to 0 point. This program gives. Now we have to develop this program. We have to write a. We have to use for loop, and we have to initialize properly, so that we'll get y values at different given x values. And finally, we'll compare this program output with ODE 45. Why? Because this is also dependent on, this program is dependent on Rangi-Gupta fourth order method. Am I correct or not? We compare this output with the ODE 45 solver, whether we are getting different answer or same answer. Okay, that is my idea. Okay, tomorrow I will continue this problem. Okay, continue this program. So if you want any clarification, there is a, this is also again my scholar did a small mistake. In YouTube, we go to YouTube. That is RK method, I think. RK method, fourth order, using MATLAB. This is my program. 2.7K views are there. Maybe this is around 1 year ago. So use a 10 minutes video. 10 minutes video. The problem is, if you want to, audio is the problem here. Again, audio is the problem. Some videos are there, beautiful videos are there on YouTube, actually. This one among them is this one. Okay. The audio problem, but I explained very nicely in this video. Again, I will change this program. It's a old style. I will write in new style. Okay, okay. Before coming to this, just view this video. Yes, so that you can get a clear idea. Okay. So tomorrow I will continue this class. Next tomorrow I will solve second order and higher order differential equations. After that I will take another topic. So rank put of fourth order. This is Srinivasa Panda. You remove this. If you type like this you will get third one. Third one is my video. Rank put of fourth order using MATLAB. So I'm leaving today. Tomorrow I will continue this class. If you have any doubts, you can ask.